again, there's 76 questions on the final, and then today we're going to review a few. Questions 1 through 8 from the review. It says, state if the triangles in each pair are similar. If so, state how you know they are similar, and complete the similarity statement. The rules that we use for similarity were side, side, side. Right, 3 sides. Another rule that we used was side, angle, side. That was another one that we used. And the last one we use for similarity is angle, angle. So 2 angles is enough for similarity. Remember, similarity, what it means is that the figures look the same, but one of them can be bigger than the other. So what I'm going to look at question number 1, I know I can mark this angle with this angle because there's an X form, opposite angles are equal. So the angles, if I'm going to use angles, the angles have to be equal. If I'm going to use sides, they have to be proportional. So looking at this triangle, the little one, my numbers are 12 and 12. Let me list them from small to large. Because they're the same, I'm just going to put 12 and 12. And then looking at the other triangle, my sides over here, let me list them from small to large. 44 and 44. There's 2 ways how we can check for proportional. One, we can cross multiply, and the two things should be equal. That's one way how to check for proportional. The other way is simplify your fractions, and they should simplify to the same thing. This one, I think we can already see that they are proportional because it's the exact same fraction. So 12 times 44 is equal to 12 times 44. Right? It's the same thing. I'm not going to multiply it. Or if I was to simplify my fractions, I know they simplify to the same thing. So I'm using 2 sides and the angle in between. So I'm going to complete this by side, angle, side. So I'm going to say MLK is similar to triangle MRS. This case, because it's an isosceles triangle, MRS, MSR, it will work. Order does matter, but because it's an isosceles triangle, MRS or MSR works. But let me take a look at question number 2. Notice number 2, I can mark this angle with this angle. I notice that I have 2 angles from one triangle are equal to the 2 angles on the other triangle. So I'm going to use angle, angle. And that was one of the rules. I'm going to use angle, angle. And I'm going to say PQR is equal to, it's similar to triangle PGH. If you guys write PHG, it's incorrect. It's PGH. Order matters. Notice how Q and G are the same. Make sure see how Q is in the middle? Make sure G is in the middle as well. Like order matters. All right, so on the review, we have 8 questions. On the final, there will be 2. There's 2 of these. So on the review, there's 8. On the final, there's 2. So any questions on this section? Yeah.
3.
Number 3? All right. Looking at question number 3, I'm not going to be dealing with angles. Let me deal with sides. If I look at the small triangle, the measurements of the sides are 65, 30, 65, 70, and 39. Let me list them from small to large. 39, 65, and 70. Right, I listed them from small to large. If I look at the big triangle, one side is 186. I can see that one. The other side is 112. Notice how I added my 2 numbers. And then the third side, when I'm looking at the big triangle, it's going to be 181. Do notice that I added my two numbers there. Okay, so list them from small to large. It will be 112, 181, and 196. So the way we can check if these things are proportional, one, we can simplify each fraction. They should all simplify to the same thing, or we can cross multiply. Let me try to simplify. 70 and 196 Let me divide each by 7. So that's 10. 196 divided by 7 is, let's see, 28. 10 and 28, I'm going to simplify this to 5 over 14. Like I said, one way we can check if they're proportional, we can cross multiply, we get the same number, or you can simplify the fractions, and they all simplify to the same thing. If on the second one, if I divide this by 13, I get 5. If I divide this by 13, I do not get 14. But 181 divided by 13 is not 14. So you notice how two fractions are not going to be equal? So since they're not equal, they're not proportional. So I'm going to say not similar. I'm not even going to check this last one. As soon as you find two sides that are not proportional, it's not proportional. I don't care about the last one. Did that make sense? So you can simplify, they should simplify to the same thing, or you can just cross multiply, and it should be the same thing, if they're proportional. All right. Any other questions from the front? Number 4? Looking at number 4, if I look at the small triangle, I know this side right here is what, 24? This side is 24. The 24, because the whole thing was 42. I took away 18, so that's 24. For me to find this other side, the whole thing is 63. So let me take away 27, we get 36. Notice how on this triangle, the little one, my only two numbers that I have are 24 and 36. Let me list them. 24, it's smaller than 36. I list them from small to large. On the big triangle, the numbers that I have are 42 and 63. 42, 63. I can cross multiply to see they equal the same thing. My case, let me simplify. 36 over 63. Let me divide each by 9. So I get 4 over 7. Now for 24 and 42, let me divide each by 6. And I get 4 over 7. So at least the sides are proportional. But side is not enough. It would be nice if we had the angle in between, but notice angle S is used by the little triangle and it's also used by the big triangle. So we can have angle S. So I'm going to call this by side angle side. STU is similar to triangle SLK. By side angle side. Since both triangles use angle S, you can use angle S. Because technically, angle S from the small triangle, it's as big as angle S from the big triangle. It's the same triangle, the same angle, so you know it's the same measurement. Right, so we're good for the first 8. There's 2 of these on the test. Now let's take a look at question number 9. It says the polygons in each pair are similar. So I'm already telling you they are similar. Find the missing side length. Because they are similar, the sides are proportional. So looking at the triangle, 20 and 28, let me list my numbers from small to large, 20 and 28. Looking at my numbers here, 15 and x, 15 is smaller than x. I can compare with the edge of a paper. 15 is smaller than x. I have proportions. I can cross multiply and solve for x. My case, 20 over 15, let me simplify the fraction as 4 over 3. I want to deal with smaller numbers. I can cross multiply. 4x equals 28 times 3. I can cross multiply, but in my case, since I don't want to use a calculator, I'm going to simplify 4 and 28. This becomes 1, and this becomes 7. I made my numbers smaller. Then I'm going to cross multiply. X times 1 is x. 7 times 3 is 21. So x equals 21. If you have a calculator, you can just multiply straight up. 20 times x, 28 times 15. Divide both sides by 20, x equals 21. All right, so from the review, we have 9 through 16. On the test, there'll be 4 of those. Number 10. So from number 10, I'm going to use these two numbers, 10 and 16. I know 10 is smaller than 16. From the other figured, I'm going to use 15 and x. And I know 15 is smaller than x. But we can compare the length. You can cross multiply, but I'm going to simplify 10 over 15. Let me call that 2 over 3. We can cross multiply, but I'm going to simplify sideways. 2 and 16, I'm going to call that 1 and 8. When we cross multiply, we get that x equals 24. Like I said, you can cross multiply whenever, but you can simplify first if you wish. All right. Any other questions up until 16? 15? From 15, I'm going to use 32 and x. I only need 2 per side. So 32, actually x is smaller. Oh, you said 15, right? This one it said? Okay, so I know x is smaller than 32. X is smaller than 32. From the other figured, I'm going to use 24 and 18. I know 18 is smaller than 24. Like I said, we can cross multiply, but I want to simplify first. So instead of 32 over 24, let me divide each by 8. So we get 4 over 3. And so we can cross multiply it again, but let me simplify sideways, 18 and 3. So I'm going to get 6 and 1. Now when we cross multiply it, we get that x equals 24. And once again, there's 4 of these on the test. I think we're good on this section. Let me take a look at number 17. Find the missing length indicated. Leave your answer in simplest radical form. What we're going to do on this one, I remember when we covered this, I told you guys there are 3 right triangles. So if we write that 3 right triangles like this, I'm only going to use 2, but I don't know which 2 yet. If I look at the small triangle, this one, there's my 90 degrees. If you spin it around, like so you rotate it, you can reflect and do whatever. And then once you make it land on this one, the 9 will be there and the x will be there. Right? If you spin it around to make it match like that, that's where your 9 is and that's where your x is. So I have that triangle. If I look at the middle triangle, what I mean with middle triangle is this one. If you spin it around, in order to match this figure, you spin it around, this is your x, and this is your 16. And so you might need to rotate it to do that. The third triangle, it's the big triangle, which is this one. And so you might spin it to make it look like this. I'm not going to use it because I already have 2 triangles with 2 sides. So I'm going to use those 2. But if you needed a third triangle, like I said, is the big one. So the way I'm going to set this thing up will be 9 is smaller than x. On the second one, x is smaller than 16. There's nothing I can simplify. So I'm just going to cross multiply. I know x times x is x squared. Don't call it 2x because that would be adding. We're multiplying, so x times x is x squared. 9 times 16 is 144. So we have that x squared equals 144. The way I'm going to undo a squared is by doing the square root on it. So x is equal to 12. Right, the square root of 144 will be 12. There's 4 of these on the review, 17 through 20, and there's 4 of these on the test. All right. Any questions up until 20? 18? All right. So for number 18, remember all I'm looking for is I have 3 triangles. Bless you. I'm going to use 2, but I don't know which 2 yet. If you look at the small triangle, there's your 90 degrees. If you rotate it to match it like this one, your 36 is right here, and your x is right here. Like I said, if you rotate it, that's where your 36 and x land. If you look at the big triangle, so when I say big triangle, I'm looking at this one. And you rotate it, your x is going to be here, and your 100 is going to be here. I'm not even going to take a look at the middle triangle because I don't need it. I was looking at 2 triangles that I knew 2 sides of it. Like say, if you look at the big triangle and you spin it, it will match like the middle one. So the way I want to do this, I'm going to say 36 is smaller than x, and for the other one, x is smaller than 100. Cross multiplied, x squared equals 3600. You guys have a use of a calculator, so this shouldn't be that hard. X is equal to 60. The square root of 3600. We're good? Which one? 19. Okay. If I look at 19, so again, I need 3 triangles. I'm only going to use 2, but I don't know which 2. If you look at the little triangle, and if you spin it around, you have your hypotenuse x, and you have this little side 9. If you look at the big triangle, one side is x, and the hypotenuse is 25. So consider I'm looking at the whole triangle. So the small side is x, and the hypotenuse is 25. 16 plus 9? Because remember, I'm looking at the big triangles, I'm looking at the whole side. The hypotenuse is 25. I'm not even going to look at the middle triangle. The way I will set this one up will be 9 is smaller than x, and on the other one, x is smaller than 25. And the rest, I'll leave it up to you. I'll let you guys finish with number 20 as well. Remember, there's 4 of those on the 5. Now, the last section, we have 3 different figures. The first figure is a triangle. I'm always looking for the 90-degree angle on a triangle. When it comes to areas, 90 degrees are important. For triangles, multiply the 2 numbers that cross the 90 degrees. I extended this line, so you will see it has to deal with the 5. So multiplied 5 times 2.6. Like I said, multiply the 2 numbers that make the 90-degree angle. The 90-degree angle could be outside of the triangle, it could be inside the triangle, or it could be even at a corner. Like it doesn't matter where they are, just multiply those 2. And then on the triangle, multiply this by half. Or if you're using a calculator, divide it by 2. So you said what? 6.5. Thank you. 6.5. Once again, for triangles, multiply the two numbers that are, oh, I meant 1/2. Multiply the two numbers across the 90 degrees. So on a triangle, multiply the two numbers across the 90 degrees and get the half of it. Because a triangle, it's half of a rectangle. So for triangles, do not forget your half. But then, let me skip to question number 23 with rectangles. This one happens to be a square because the two numbers are the same, but they don't have to be the same. When we have a rectangle, I look at this 90 degrees, it's made by 7.8 and 7.8, so I'm going to multiply those two numbers. 7.8 times 7.8. Except they don't have to be the same two numbers, but I'm multiplying the two that multiply that cross the 90 degrees. When you multiply that, you should get 60.84. There is no half on this one because it's a rectangle. Triangles have the half because triangles are half of a rectangle. And then, so there's another rectangle for number 24. For 25, let me deal with a parallelogram. Parallelogram, they look like a slanted rectangle, so I'm going to treat them like a rectangle. The two numbers that I'm going to multiply are 12 and 8. So 12 times 8. Remember, a parallelogram, it looks like a slanted rectangle, and I'm going to treat it the way I treat a rectangle. Multiply the two numbers across the 90 degrees. So in this case, 96. No half because it's a rectangle. I know this section, you guys have three different figures. You guys have a triangle, you guys have a rectangle, you guys have a parallelogram. On your test, there'll be 4 questions. They could be all 4 different, or well, three different, or who knows? You might have this. You might have 4 triangles, or 4 rectangles, or 4 parallelograms. Like I'm gonna do a combination of 4. You know, I do everything through the program I have in the computer. I just said do 4, and it picks random 4. It could be the same figure all the way through.